So power functions are basically any function with a power on a variable. Okay? Power on a variable is a power function. K is the coefficient, A is power on the variable. So, this is a power function. The fourth root of x means x to the 1/4 power. Okay? What does the graph look like? Well, it looks like that. Okay? The power is 1/4 and the constant of variation is 1. There's a 1 out front. Okay? So this is also called a monomial function. Okay? To graph it, it's just like this, but with a factor of 3 in front. Okay? So when you graph power functions, if you have a negative exponent, if you have a negative exponent, it's defined if it's undefined if if you have a negative number, it's an exponent. Okay, that's not that important. All right, let's just go on to what you see in the homework. There we go. Exactly. Thanks for agreeing, Molly. Okay, this is a power function. The power is what is taken after the caret. The caret is raising it. So the power is 5. What's the constant of variation? Negative 1/5. Okay. Is this a power function? No, that's an exponential function. Okay. It's not a power function because x is the power. If x is a power, that's an exponential function. A power function has a real number as a power. Okay. Now, is this a power function where v equals k over y squared? Well, we can rewrite this as v equals k y to the negative 2 power. Okay. So, it is a power function. The power of the function is negative 2. The constant variation is 1, and the independent variable is k. I'm pretty sure I'm right on that. Let's just see. 2k, independent variable is y. Oops, sorry. I gift that one. K is the constant variation, and the independent variable is y. Sorry about that. Okay, here's a monomial function. What's the degree of the monomial function? 5, leading coefficient. So basically, power and constant variation mean the same as leading or degree and leading coefficient. That's what that question was getting to. Here's a monomial function. What's degree? 2. Leading coefficient is 6 pi. Okay. X to the 4/5 power. If we would graph it on the graphing calculator, x to the 4/5 power would look like this. What's the domain of the function? Can you take 0 to the 4/5 power? And actually, you can take 0 to the 4/5 power, because 0 to the 4/5 is still 0. Can you take negative 1 to the 4/5 power? Well, it's really negative 1 to the 4th and the 5th root. So actually, I did this wrong. I graphed this a little wrong, because it's not quite like that. It's like So it would be negative infinity to infinity for this one. Let's see what the graphing calculator does when we bring that up. I restarted it, so W A B B boom. So if we graph y equals clear, 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 x raised to the parentheses 4/5 power. Yes, I could have made that a fraction if I wanted to, but it works this way too. Oops. Zoom 6 gets me on my 10 by 10 window. Ooh, it's not quite what I thought it was. Goes more like that. Okay? So if you have a graphing calculator, check out the graph before you decide what the domain is. Okay. The volume of the cube varies directly as the cube of the side, so the side cube. The cube of the side is the side cube. Varies directly, there's a constant of variation. Okay? So V equals KS cubed. The volume of a square prism with a fixed height x, h, varies directly as a side squared. So hs squared. If force equals mass times acceleration, where F is the force and m is the mass, and a is the acceleration, the mass, so the force varies directly with the mass and the acceleration, which is choice B. And those are the 9 types of problems that you'll see. Short, easy, Friday. Yes.